Okay, so we are on quadratics notes day 4. So where we left off was factoring trinomials that looked a little bit different, and actually some of them were binomials, some of them were trinomials with terms in different spots. And we also looked at a trinomial that had more than one answer. So that's the first thing that we are going to look at. Is there more than one factored form for 3n squared plus 9n plus 6? So let's go ahead and see. So we're going to make our box. We should be experts at this by now. So 3n squared goes in the first box, 6 goes in the last box, and then you can make your x. You find the product of the diagonals, which is 18n squared, and then we need the sum to be 9n. So I need two numbers that multiply to 18 that add to 9. And so the two factors would be 6n and 3n. And it doesn't matter where they go. All right, so let's say I find the GCF of that first column. It's going to be 3n. So 3n times n is 3n squared. N times 6 is 6n. And 3n times 1 would be 3n. And 6 times 1 is 6. So we end up getting 3n plus 6 and n plus 1. All right, let's say we did that a little bit differently. So I'm going to go ahead and place the terms in the boxes in the exact same order. But this time I'm going to go ahead and find the GCF of that first row. So if I were to do that, I would get 3n, and 3n times n would be 3n squared. 3n times 2 would be 6n. N times 3 would be 3n, and 2 times 3 would be 6. So I end up getting n plus 2 and 3n plus 3. So these are my two answers right here. So why are we thinking that we're getting two answers? Well, if you remember from the last time, it's actually because we could have taken out a GCF before we started. So looking at this term, or this binomial, for example, I could factor out a 3 from that. So when I do that, I would get 3, and then I would get n plus 2 times n plus 1. All right, looking at this one, I can't factor out anything from n plus 2, but I could from there. So if I factor out a 3, I would get n plus 1, and then I would still have n plus 2. So what we're seeing is that if you don't factor out your GCF right away, you will get different answers. Not necessarily different, but they're not simplified. So whenever you have a GCF, your first steps should be to factor out that GCF. So the next part is right here, we're looking at, without factoring, predict which quadratic expressions below may have more than one factored form. So we just kind of talked about they're going to have more than one factored form if there is a GCF. So looking at 12t squared minus 10t plus 2. Does that have a GCF? What number goes into all three of those terms? It's 2. So that one definitely would have two different forms. Looking at the next one, 5p squared minus 23p minus 10. Does that have a GCF? No, there's no number that is a factor for all three of those terms besides 1, which wouldn't count. The next one, 10x squared plus 25x minus 15. Is there a greatest common factor for those three terms? The answer is yes, it's 5. And the last one, 3k squared plus 7k minus 6. It doesn't seem like there is a GCF for that one. All right, so we're going to go ahead and in your groups, but in this case with me, we are going to look at an expression, 10x squared plus 25x minus 15, which is actually that the last one that we just did right here. And we're going to go ahead and factor that completely. All right, so I have 10x squared plus 25x minus 15. So we want to look, what is the greatest common factor? And we already decided earlier that it was 5. So what you're going to do is like what we did at the very beginning of this factory unit, where we would just take out a GCF. So if we take out 5, we get 2x squared plus 5x minus 3. All right, now that I did that, now I'm going to go ahead and factor 2x squared plus 5x minus 3. And keep in mind, I still have that 5 that I will have to include in my final answer. So I'm going to place 2x squared in the first box, negative 3 in the last box. I make my x, the product of that diagonal is negative 6x squared. And then the sum would be 5x. So I need two numbers that multiply to negative 6x, but add to 5x, and that would be 6x and negative x. You place those numbers or factors in the boxes, and then I find the outsides. So the GCF of 2x squared and 6x would be 2x. 2x times x is 2x squared. 2x times 3 is 6x. X times negative 1 is negative x. And 3 times negative 1 is negative 3. So what I got is that my factors were x plus 3 and 2x minus 1, but I also have to put that 5 in front. So really, this is the same thing as we've been doing. The only difference now is that whenever you factor, your first step should actually be, can I take something out? Is there a greatest common factor? And if there is, then you would take that out, factor as normal, and put that GCF in your final answer. And that's it.